Today we want to look at max and min problems. And there's really two parts to this, two goals that we're going to try to do here. First is to write a polynomial for a given situation. So we're going to get some problem that we have to come up with the function, come up with the polynomial. And then once we come up with that polynomial, we want to try to find the max and min value for it. What's the maximum or minimum depending on the situation. So the first step is going to be to write the polynomial, and for many people, that's the harder of the two steps. And then we'll just use our calculators to help us try to find what that maximum or minimum value is, like we did last week, and then relate it back to the problem. So to get us started, I want to just get us kind of thinking in this way and kind of getting our brains going this way. So consider this rectangle. And I tell you that the perimeter of this rectangle is 40. So the distance around all four sides is 40. And I also tell you that this side is 5. What's x? Could I find x? Well, I know from my rectangles, if this side is 5, then this side over here also has to be 5. So if I know the total distance around is 40, and I have 5 on this side, 5 on that side, that is 10. So if my total distance is 40, I can say, well, I have 30 left for the top and the bottom. Well, if half's on the top and half's on the bottom, then I know this side is 15. Let's try another one. Perimeter is 40 all the way around. That means this side is 12 and this side is 12. So how much do I have left for these two sides? Well, you can pause the video, or I'm going to give you a few seconds for you to try these two and see if you can determine what is side x. If you're not ready yet, you may want to pause the video, otherwise we'll continue on here. This side is 5. That's 10. That means if I take that 10 away, I have 20 left for two sides. So that means this side is 10. Over here, this side is 12. So this side is 12. So that's 24. I have 6 left. I divide that on my two sides, and I get each side is 3. Understanding that with a rectangle is going to help us as we go forward. Now, what happens, similar problem, change it up just a little bit. We're going to have 3 sides. So I'm stretching our definition here of perimeter, but go with me. What if the length of these 3 sides is 30? And this side is 12. What's x? Well, now I could say 30 minus 12 is 18. I divide that between my two sides, and I get 9. A little bit different way, now I have 15 on this side of my 3 sides. That means there's 15 over here. So what's x? So now I subtract 30, and I get 20. But do I need to divide it in half? No. This side is 20. It's only one side. I don't have to divide it in half. So let's look at some problems now that we kind of understand this about perimeter. Let's look at an example. Suppose you have 100 feet of fencing to make a rectangular dog pen. If you want one side of the house, if you want to use one side of the house as one side, find the dimensions of the pen that give the greatest area. So we have our steps. Find the function, find the max. Now we have this other one domain I'll get to in the middle here. First thing let's do is draw a picture. So I have this long house up here, and I want to find this rectangular dog pen. And I have 100 feet of fencing to make my fence. And just that will give me different areas. Let me show you what I mean. Here is a rectangle. My perimeter is 20. So if I come over here, you can see if I add my width and my length, I add up to 10. So overall that's 20 perimeter. And over here is my area. And up here is I can drag the shape of my rectangle be different. Long and very narrow, I only have an area of around 2. If I drag it this way, I get the area almost to 24, almost 25. As I keep going, I get long and narrow and it gets small. So at some point, I have my maximum area. And we can see in this one, if I just drag it, you can see I get off a little bit here just because of rounding on this program. Going back down. Keep going. Right about there. Approximately. And if you've done this before, you know the maximum area is going to be when you have a square. 5 by 5. However, here we don't have that because we have a house on one side. So it's not going to be just a square. But what maximizes our area? First, we have to decide what side do we want to label X. Think back to the problems we did earlier. Do we want to make this X? Or do we prefer to make this X? Both ways work. One way is not easier than the other. You can do it either way. I'm going to make this X right here. So if this side is X and this side is X, and I know I have 100 feet to make the green. So I've used X over here, I've used X over here, that's 2X. What I have left for this side is 100 minus 2X. So I draw the picture to help me. Now I want to find the area. Well, the area of a rectangle is my width times my length. So there's part A. Now let's look at part B. Find the domain. Now, I didn't multiply this out on purpose to help us with the domain. The domain are the values that X can be. These are the X's that work, if you will. Now, if I look at my problem, mathematically, with just an equation, I can say, well, X can be anything. X can be 400 if I wanted to. Now, in this problem, X can't be 400. If X is 400, then this side would be negative. That doesn't make sense. So I know X has to be greater than 0. I can't have a width of a dog pen that's 0 or negative. That doesn't make sense. But also, X cannot be as big as I want it to be. One, it can't be over 100 for sure. I don't have 100 feet. But secondly, if you look at this equation down here, X really can't be any bigger than 50. Because if X was 60, let's say, the length of this side would be negative. I can't have a negative length or width. So 0 to 50 is all I can have. Because I can't have anything, any length be negative in a real world kind of problem. So now we want to find the max. We're going to do that by graphing it. So I'm going to put my equation, X 100 minus 2X. And if I just hit zoom 6 like we did before, can't really see much. So I gotta go to my window. Now I know my X's can only go from 0 to 50. That's all that matters. That's my domain. So I'm gonna grab 0 to 50. I can see something going on here, but I can't see where it's at. So I'm going to hit trace. And look where it's at. It's way up here at 1,200. So by using your trace button, it tells me, okay, I'm not going far enough up. So I'm going to go up higher. I'm going to go up to 1,500. A little bit bigger. And there is my equation. And you can see the area changes. Just like here, as I drag this, my area changes. So this shows a formula. So notice here as I change this is a different problem. But as I change, I get different areas. This graph shows down here is my x. This is then the area that I get. Well, I want to find the maximum. So we use our maximum button. And I go a little bit to the left, hit enter, a little bit to the right, hit enter, go back and guess, hit enter, and there's what I get. My maximum is there. So let's bring that over here, and let's blow it up a little bit. So I get to that. Now, what does that mean? That means my maximum x of 25 goes right there. So it says find the dimensions. So if x is 25 by, now let's also put 25 into here. 2 times 25, 50. So my dimensions are 25 by 50. So my area of my dog pen, or the dimensions, are 25 by 50. Notice this problem doesn't ask me what is the maximum area. That's for the dimensions. Now if I actually wanted to find the area, that would be 1250. This answer right there. Let's see, what's our units? We're in feet, so this is in feet squared. So when you do this maximum on the calculator, it gives you two things. The maximum x, but then what your maximum area or the maximum thing you're trying to find. So get another one. Different kind of problem. Sam's Pizza sells a slice of pizza for $1. For every 10-cent raise in price, Sam loses 5 customers. If Sam has 200 customers now, what price maximizes his income? Now, a couple of things to think about here. The way it works in business is if you sell something, you have to determine the price. Let's say Sam. If Sam's Pizza sold one pepperoni pizza for $50, nobody would buy one. But if somebody did, Sam would make a lot of profit on that pizza because it doesn't cost $50 to make it. Likewise, if Sam only charged $5 per pizza, he would sell a lot of them. I'd buy a lot more. They're only $5. However, he wouldn't make enough money to make a profit to be able to stay in business. So one of the things they have to do at any kind of business is determine how much do we charge. So that's what we're trying to figure out. And they say they've done some research that they know if they raise the price 10 cents, 5 people are going to say, okay, you know what? That's too much. I can no longer buy it. Okay? So let's first look at kind of getting a grasp of what this problem's asking. What is the current income? How much is Sam currently making? Well, he currently sells, we're going to look at the price, times the customers. And currently my price is $1, and I sell 200. That means Sam's current income is $200. But let's say he increases the price 10 cents. Then he would make $1.10. but he'd lose 5 customers. He would only have 95. What's that do though? 110 times 195, 214. 50 cents. So by raising the price, he actually made more money. Now he lost some customers, but he made money. So our question is, how do we balance that out? How do we maximize the income? So here's what we're going to do. Let's consider the price. Currently the price is $1. And we're going to raise it 10 cents. So I'm going to come over here. I'm going to say let X be 10-cent raise. So if I raise it 10 cents, X is 1. If I raise it 20 cents, X would be 2. So to make that work, my price is going to be 0.1 times X. 20 cents, raise it 20 cents, X is 2. Now, why I do it that way is because I'm going to multiply by my customers. And if X is 1 and I raise it 10 cents, I'm going to lose 5 customers. If X is 2 and I raise it 20 cents, I put a 2 in here and I would raise 10 customers. So there's my income. I want to graph it to find the max. Now let's talk domain here also. Okay. Once again, you can't raise it forever. Now in this case though, I could have negatives, right? You could go back, you can actually lower the price. But we know that raising it's what we're going to do. So we say it's got to be positive. Now, how big can it go? Well, if we look here, the price can't be negative. So X can only get so big until this is negative. So it can't get bigger than 40. Because once it's bigger than 40, I have negative customers. That's not possible. So let's graph this. Once again, notice I'm not simplifying it. I'm just leaving it like it is. There's no reason to waste my time and energy trying to FOIL it out. I'll change my window. It's already 0 to 50. Let's hit graph. I have 0 to 40. Doesn't go quite as high, but we can see my maximum. So let's go to our calculate. Go maximum. I need to go to the left of this maximum. A little bit further, calculator slow. Hit enter, go to the right. Hit enter, guess I'm not going to worry about. And I get to there. Now, as you look here, you think, well, 14.9999999999999. Okay. Calculator's rounding off. That's 15. So my X is 15. Now, this here, that's my income. That's my max income. So notice compared at 200, 214, now I'm at 312. That's even more. But the question is, what's the price? So it's 1 plus 10 cents times 15. That's 15 10-cent raises. That's $1.50. So my new price is $2.50. Now you may think, well, that's too much for pizza. But notice here, if I do a little calculation, let's look at my customers. 200 minus 5 times 15. That's going to be 200 minus 75. So I now only have 125 customers. So I've maximized my income, I've raised my price, and I've lost a lot of customers. This is the second part of business. This may have increased your income, but now you've made a lot of your customers mad, and it's balancing that out. Making a profit, keeping your customers happy so they continue to come back, but also charging enough. And a couple of problems like this on the homework will be given. We'll say somehow through market research they've determined these numbers to figure it out. Let's look at all right, we're going to stop there. We will continue in class tomorrow with this, the rest of your notes. And then we will work on the homework in class tomorrow.